today about quantum physics. It's really late at night, but that's when the mad scientist works best, so I figure why not? We'll make a little science video. So today we're going to talk about a specific property of particles in quantum physics, and we're going to call it superposition. Now, what superposition means is that a particle can assume all of its states at once. Kind of like if I were to spin my head to the left, while to my right, and to the left, it would be in a state of all positions at once, kind of like this. Or so it looks on the camera. I'm just taking advantage of, that only has so many frames per second. So, how do we know things can be in superposition? Well, we do this thing called the double slit experiment. And you can use anything for the double slit experiment. You can use tea bags, pills, shoes even, or phones. But usually we use things that are, phone, yeah, by the way. So usually we use things like electrons or buckyballs, Buckminster fullerene. They're pretty cool. They're like atomic soccer balls, but that's beside the point. And electrons, photons, buckyballs, those are the things that have been used. And what the double slit experiment is you take like a piece of paper or something like that, and you cut two slits in it right next to each other, and you fire the electrons through it. Now, ordinarily you'd be thinking that it should look something like this on the detector. Just two stripes of photons that have slipped through the paper. But really, and what surprised a lot of scientists is that we ended up with something that looks more like this. So they were thinking, okay, well, maybe because they exhibit, wave-like behavior, the electrons were interfering with each other, going through the thing, and that's how we arrived at the interference pattern. It's like, when you throw two rocks into a pond and then the waves kind of, just intermingle. Really cool pattern. So we decide, well, we're just going to throw one at a time. And so they thought, maybe it'll end up with that little two-stripey thing. But no, even firing it one at a time, we still get our handy-dandy interference pattern. So what causes this? Well, it's the fact that the particle is in superposition. It means it travels every possible path it can take to its destination. So granted, by not being able to go through the paper, it's only limited to those two slits, but it is going through both slits at the same time, which is really kind of cool. And the reason we can't do it with things such as shoes or cellular phones is the fact that on a macro scale, the probabilities average out over large scales. And, well, there really isn't a whole noticeable wave function for them. Can you imagine if the Planck's constant were bigger, though? I mean, Planck's constant is kind of like what governs these things. It's a number the guy came up with to fit into a bunch of formulas, and I'm not going to bore you with the details, but let's just say that if Planck's constant were bigger, we'd see the effects of quantum physics on a much larger scale. So anyway, back to what I was saying about the superposition. We know it takes every possible path. Heck, it goes through holes in Swiss cheese on at Moe's Diner for all we know. But yeah, so they decide, all right, well, what if we try to measure it and see if the particles, can be seen in both places at once. And then something interesting happened. By observing the particle, we collapse the wave function, meaning we've taken the probability of where the particle might be and collapsed it to exactly where we have found it to be. And when we do that and fire one at a time, we get this. We get the two stripes because the particle isn't interfering with itself going through both slits. It's actually going through one or the other when it's being measured. And it's actually really cool if you think about it. And I mean, it sounds really counterintuitive, but the fact that it could exhibit wave-like and particle-like behavior, I mean, that's huge. I mean, let's just say it's really awesome, and it's slightly maddening, but hey, that's why it's on Maddie's Mad World of Science.